In this lecture, we will introduce reverse engineering malware using Ghidra. So by using Ghidra, you will be able to analyze executable binary files containing malicious code. This section is a great opportunity to put into practice the knowledge acquired during the first sections of our course. And to put this knowledge into practice, we will analyze the point of sale POS malware. So this malware basically scrapes the RAM memory of point of sale systems to steal credit card and debit card information. So here we will first search about the point of sale malwares. Let's open the Google Chrome here and point of sale malware. And as you can see here, POS malware is a type of malicious software designed to steal a customer's personal information through the point of sale devices, POS devices. Let's see what POS device is. And here, this is the POS device here. So this malware is designed for this POS devices. So here I have two files. In the first file, we have the malware and SYS file, which you will learn what this is used for. And after that, we have the password for this zip file. So before installing this malware, you need to run this malware on sandbox or virtual machine because it might infect your main machine here. So firstly, turn off the real-time protection. So this is a executable Windows malware. And here our approach will start by setting a safe analysis environment, of course. And then we will look for malware indicators in the malware sample, and finally we will conclude by performing in-depth malware analysis using Ghidra. So here for technical requirements, you will need to have the virtual machine like virtual box. Here in previous lectures you learned how to install the virtual machines into your operating system, and also you will need to download the samples which is attached to lecture section here. And at the time of creating this course, the public version of Ghidra has no debugging support for now. So this limits the scope of Ghidra to static analysis, meaning files are analyzed without being executed. So, but of course, Ghidra static analysis can complement the dynamic analysis performed by any existing debugger of your choice, such as x64DBG, WinDBG, and OnlyDBG. So both types of analysis can be performed in parallel. So setting up an environment for malware analysis is a broad topic. So we will cover the basics of Ghidra for these purposes, and keep in mind that the golden rule when setting up a malware analysis environment is to isolate it from your computer and network. Even if you are performing static analysis, it is recommended to set up an isolated environment because you have no guarantee that malware won't exploit some Ghidra vulnerability and get executed anyway. Because here Ghidra also has some vulnerabilities. It should be like CVA 2019 17664, and here this is a Ghidra malware. So CVA 2019 17664 is when executing Ghidra from a given path, the Java process working directory is set to this path. So then when launching the Python interpreter via the Ghidra code browser window of Python, Ghidra will try to execute that cmd.exe program from this working directory here. So as you can see here, the base score is high here. And in order to analyze malware, you can use physical computer, restorable to a clean state via hard disk drive backups, or a virtual one here. So the first option is more realistic but slower when restoring the backup and more expensive here. So You can also isolate your network. This is a good example to illustrate the risks is ransomware encrypting the shared folders during analysis. So you can also use the VirtualBox or VMware for your creating virtual machine purposes. And now let's look into our malwares here. So as you probably remember from previous lectures, Ghidra works with projects containing 0 or more files. So this here, this malware consists of 2 components. So actually, let's call this the Alina malware, because in reality, actually, this malware called by the internet community as Alina here, the code name. So Alina malware here consists 2 components. Can you see the screen? Yes, perfect. So Alina malware here consists of 2 components. A Windows driver rt.sys and a portable executable spark.exe. So there are a compressed Ghidra project like this here, malware sample 1.zip, containing both components, can be found in the lecture attachment section. So if you want to get the Alina malware sample as is instead of Ghidra project, you can also find it in the lecture attachment sections here. And because we also compressed and protected with the password infected, we also have this file. So the password is infected, and it's quite common to share malware in this way so that it does not accidentally get infected. And next we will try to quickly guess what kind of malware we are dealing with in general terms, and to do that we will look for strings, which can be revealing in many cases. So we will also check external sources, which can be useful if the malware has been analyzed or classified. So finally, we will analyze its capabilities by looking for dynamic linking library DLL functions. So here DLL functions, and we have the SYS and exe here. So now what we're gonna do is we will start a Ghidra here, the new project. And after that, we will start analysis in next lecture. I'm waiting you in next lecture.